Hello, peoples. So you're now going to go over correlation and experimentation. So this is really where we're going to see like how we can actually go about answering a question in psychology. So we want to look at the basics of performing a study and analyzing it, designing it, that sort of thing. So this is going to be exciting because there's actually some math involved. Yay! Never mind.
He loves math.
But this will kind of give you an idea why you need statistics. Usually you will have a statistics requirement, but it's very, very simple statistics. But I also teach that class as well. Starting off with correlation. Correlation means that two things are
related.
Yeah, two things are related. So one way of thinking of a relationship is when one increases, the other variable increases. So what would be one thing that would increase with study time?
Your GPA.
Yeah, GPA most likely will increase with the amount of time you study. And it'll maybe look something like this. Chickenpox going like that. And if you get fancy and advanced, you may even have to plot a least squares regression line. But don't worry about that, not yet. Now, this is something that shows that these two variables have a positive correlation. What are two variables that would have a negative correlation? No choice. So what would be with social media time?
The amount of sleep.
Sleep, yeah. Sleep. Let's just say sleep. To say, some ink from this marker. So maybe you get a bunch of chickenpox or dots looking like this, right? And the least squares regression line would look something like that. And this is an example of a negative correlation. Yeah?
Yes.
Now, in statistics or in psychology, we're going to use a correlation coefficient. Correlation coefficient, which is going to be a number. And what's the letter we use for this?
Lowercase r.
Yeah, lowercase r. I know that correlation doesn't start with r, but I believe this is because of Pearson's coefficient or something like that. Don't hold me to that, but I think so. But yeah, it's lowercase r, and this value will always be between 1 and -1. The more closer it is to 1, more positive. The closer it is to -1, the more negative. So maybe we could say this is about like 0.8. It's positive. And we could say this is about -0.8. Let's say -0.7. Can the camera see that?
Yes.
All right, cool. Some good camera. Now, there's also lots of things in the real world, that aren't correlated, right? So maybe like number of pets and your height or something. So when two things are not correlated, you're going to see a bunch of just dots that are all randomly scattered. And the least squares regression line will probably be something like this, horizontal. And in this case, the correlation coefficient will be close to 0. Now, in real life, you're never really going to get a value of -1 or +1. This is just a mathematical number that, in theory, you would get if two variables are perfectly correlated. So don't ever expect that, but there are a few things that maybe are close to that. Like maybe like your height and your wingspan. Drawing a blank, but yeah, there's some things that are there's really nothing in real life that's going to be perfectly correlated. Questions, comments, concerns?
No, you're just really into stats.
Yeah, of course I love stats. All right, now let's look at an experiment. So let's say we want to. It's an experiment we want to do. I was mentioning it earlier.
It was about if you, like the amount of time you talk about your personal life and how good the students do in your class.
Oh yeah. This is something that comes up with me every year. So like, let's say I want to figure out how let's say students' performance how the students' performance in my classes were related to how much I talk to them on a personal level. Which is how would you say it? Personal talk?
Yeah.
Personal random talk. So like I'm always wondering if like, hey, if I talk more to these students, will they be more motivated to do better in my class than another class where I'm just doing like regular math lectures? Does that actually affect them? And it's always like a question, like if they like the teacher, like they'll do better. But I'm always wondering if that actually is true. Of course, I like to always have random talk. I can talk about anything, but I'm really wondering if like how much that affects them. So let's say like I would have 3 classes or 3 class 1, 2, 3, and for the first class I would just act normal, like how I normally do. I wouldn't make an effort to talk a lot or talk a little. Just I would teach them like normally. We call this a control group. Why do we have to have a control group?
So they can compare it to the other groups.
Yeah, good. Yeah, you want to have some sort of comparison, a baseline. Let's say my second class, period 2, I talk a lot. I'm not telling them all stories about how good I was in high school and how I got straight A's and I was good enough at school, but let's say I entertain them with my random high school and life stories. So I talk a lot there. And period 3, I'm just serious. I'm all about business. Serious. So I have three types of treatments, you can say, 3 levels, and then I would end up measuring. What would be a good way to measure, or what can I measure?
The grade in the class.
Yeah, let's measure their grades and see like how it compares. Maybe just take the average, maybe X bar, I guess. Again, don't worry about the stats, but this is just the average of group 1, group 2, group 3, and see how like it is affected by my demeanor and attitude in class. Questions, comments? Does that make sense?
Yes.
And these are freshmen, remember? These are freshman students, so they could grow and change a lot during that year. Now, there are some issues that can arise and some arguments that people could say, like, well, like let's say this class does really well, and so what could someone say like, oh, it had nothing to do with you were talking a lot. It had to do with let's say had to do just because they were highly motivated. What do we call that type of thing?
A confounding variable.
Yeah, we have to be aware of confounding variables. Like maybe I get a group that's just super motivated. Maybe it's earlier in the day. Maybe they all have like a tutoring class or something. Any other confounding variables you could think that could affect my results?
If one student comes up to you and starts talking.
Oh yeah. Maybe the one class is just more talkative and like coming up to me and talking to me and just can't they they trick me, or how there's some teachers you can just get to talk, and sometimes I'll admit that I'm one of those.
Yes.
Yeah. So yeah, I have to be aware of these variables. Because some people are just more naturally talkative than others. And maybe one class loves basketball, another one doesn't. I'm obviously going to love basketball class much better because they're going to be better people. Yeah. So we have to make sure that we think about these random variables, or not random. We have to make sure we think about these confounding variables, and that's going to be when we get into the stats or more deep into like the experimental design part. Anything else you want to add?
No. Nothing else.
Now the last couple of definitions, single blind, double blind. Talking about like another type of experiment, like in drug companies, medication companies, pharmaceuticals. They're usually trying to develop something to help maybe with depression, maybe with staying awake. You want to make sure that you don't bias the results and that the patient also doesn't bias it. So like we usually will give and let's say we're designing a study to see if one pill helps someone stay awake better than another pill. We have to make sure that the patients don't know which pill they're getting. So one may get a fake or placebo pill while the other one gets a real thing. There are other cases though when maybe I'm going to be biased because I want my pill to work. So I also have to make sure that I don't know which one gets what pill. That way I don't like maybe rate their depression when they take a test, or maybe when they rate how they're feeling the next day or the next week. That I'm gonna say, oh, he feels pretty good. It seems like he's like my pill worked. So we have to be aware of our own biases and make sure that we we apply a single blind or double blind study when it makes sense to, and usually more often the better, as far as I can be off the top of my head. But all right, anything else?
No.
I will stop there.